Greetings and welcome to the Team Canada's Cybersecurity Risk Assessment presentation. The defense of Canada's sovereignty now extends past its borders and airspace. Interconnectivity has allowed the world to grow leaps and bounds, but has also opened the world to new and dangerous threats. The world's reliance on electronics for communications, monitoring, manufacturing, and security has spurred development and growth, but also developed a critical point of failure. In this presentation, I will discuss the current defensive measures we have in place, the threats that challenge these defenses, and the weaknesses that exist in our defensive systems. Our main defensive measures are broken down into three categories: authentication, authorization, and access control. Authentication, something you know. For the process of authentication, passwords and usernames are the backbone of the procedure. Government standards state that a user's password must be no shorter than 10 characters using upper and lowercase letters, or no fewer than 8 characters using letters, numbers, and special characters. Something you have. Tokens function as an authentication process that a user must possess. A digital token will be synchronized with the computer system it is intended for, and will generate an access code every 30 seconds that the user must use to gain entry to the desired network or system. Something you are. The final process for authentication comes in the form of biometrics. This utilizes physical characteristics of the user that is as near to impossible to be faked as can be achieved. This comes in the form of fingerprints, retinal scans, or even user input pacing. Additional security is gained when using two-factor authentication. This process requires that a user confirm their intention to log into a system on a third device. For example, when a user is logging into their workstation, two-factor authentication will send a code to a registered device, usually a cell phone. This one-time code is required to complete the login process. This ensures that even if a user's username and password are compromised, an attacker will also need the user's registered device to complete the login process. Digital signatures require that web traffic originate from a web server that has been authorized by the Government of Canada to send traffic to the network. Authorization is the second stage in the triad of network security procedures. Authorization is the process of granting or rejecting access to a computer, network location, or physical location by determining the authenticated user's level of access. Once a user has been authenticated, the network will determine the level of access that has been granted to the user by the network administrators. Network admin will use several types of access control policies to establish a user's level of authorization. These authorization levels are stored in a domain controller, such as Active Directory, and checked each time a user attempts to log in or access network resources. Access control is the final component in the network security procedure. Access control is broken down into two elements: physical access control and digital access control. Physical access control governs how humans are made to authenticate themselves and prevented from accessing locations without authorization. Walls, doors, fences, and locks are forms of physical access control. Physical authentication can be performed by access control systems such as a smart card reader, keypad, iris scanner, and combination lock. Authorization takes place through knowledge of passcodes and combinations, or through domain controllers determining if access cards are valid. The intersection of both authentication and authorization comes in the form of a guard manning security post, checking someone's identification and referring to an access list if they're authorized to enter the location. Digital access control governs what network resources and locations the user is permitted to access based off of one of several conventions. Mandatory access control. This convention is applied for an area where confidentiality and classification are paramount. Administrators determine the level of authorization required for a network location or file and give users the level of authorization. Familiar levels would be confidential, secret, and top secret. Discretionary access control. This is a convention that allows network administrators to establish their own authorization requirements as they see fit. Rule-based access control. This convention is utilized to aid network administrators in large organizations. Instead of having to set permissions and authorizations for every user in an organization, a role can be established around a job function. With this role established, a network administrator can add a new user to that job role, giving them all the necessary accesses to to perform their job. Rule-based access control. This convention allows a network administrator the ability to set specific requirements for access to files and locations. For example, if an organization is concerned about users working late or using workstations for non-business activities after work, the network administrator can set a rule that workstations will be locked out after 1700 hours to force employees off of their computers. Our current weaknesses can be broken down into three main sections: weaknesses in our people, weaknesses in our policy, and weaknesses in our technology. Both the most dangerous and easiest to remedy weakness is our user base. Poor training leads to users not using strong passwords, reusing passwords, or even leaving them on post-it notes near their desk. Additionally, employees need to be aware of social engineering attacks such as email phishing, social media mining, or even tailgating into a secure location. Innocent mistakes can be costly if exploited by an attacker fortunate enough to discover the opportunity. However, a malicious employee inside the building can be much more devastating. Insider threats are particularly dangerous, as a malicious employee rarely raises suspicion when accessing data or moving about a facility. An insider threat can cripple a business by leaking information on or installing dangerous malware onto the network. Finally, guests of employees or clients to the company can also pose a threat. Either through benign actions or malicious intent, a guest that can access our network through an open port or Wi-Fi can lead to dangerous breach of security. Weak data review and security policies can leave an organization open to malicious cyber attacks and damaging insider mistakes that can cost a company significant sums of money in lost productivity and data. Most importantly are the security policies that prevent unauthorized access and track user traffic. Access log review is a key policy to put in place to help discover and track potential insider threat. Access logs keep a record of all users who access a file or network location. Regularly reviewing these logs can show unusual user activity and lead security personnel towards a potential threat. Database audits are a crucial data management tool that protect the integrity of company data. Regularly auditing the integrity of a database and the traffic of data in and out can help security personnel discover if malicious actors trying to remove sensitive data or trying to upload corrupting malware or false database information. Password control policies govern the strength, frequency of change, and minimum history of a user's password. Weak password control policy leaves a network susceptible to hacking from a user's compromised credentials or a brute force password crack. Outdated hardware can leave a gaping hole in a network security posture. Security departments that allow old hardware such as firewalls and routers to remain in their network architecture risk known hardware exploits being used to gain unauthorized entry into the network. Without regular security patches from application developers and operating system developers, security personnel open the door to software exploits to be used by insiders and outside attackers. Networks that utilize unsecure network protocols leave themselves open to packet capture, network sniffing, and man-in-the-middle attacks that steal data moving across the network unencrypted. Attack vectors are broken into three divisions: hardware, software, and human error. Routers present an attack vector in the form of network access points, the connection to the open internet, and through a broadcast Wi-Fi if that is enabled. Open network jacks present dangerous attack vectors, as anyone who has a network device and a connection cable can make a direct connection into the network, bypassing most external security systems. USB ports pose as an attack vector, mostly to insider threats. Malicious employees will use USB ports to exfiltrate data or to upload malware that would otherwise not get past email or security firewalls. A successful SQL injection can read sensitive data from a database. It could also successfully issue a command that would modify the database, administer operations, recover file content on the database management system, or even command the hardware's operating system. An attacker can use a cross-site scripting attack to send scripts to an innocent user whose browser basically has no way of detecting that the script is not trustworthy, thus executing the script. The malicious script can then access cookies, tokens, or other sensitive materials stored by the browser. This attack vector is also a type of injection targeting web applications in the form of side script. Clickjacking occurs when an attacker uses transparent layers on a website to trick users into clicking a button totally separate from what they intended. When this happens, the user is routed to another page, application, or domain. In some cases, the user can be tricked into typing sensitive information such as passwords or financial information in a totally different page. Remote file inclusion attacks allow for the inclusion of a file that exploits mechanisms implemented in the target application. This inclusion can lead to code execution on the web server, denial of service, and sensitive information disclosure. Session variable overloading is also known as session puzzling, and it occurs when an application utilizes the same session available for more than one purpose. Thus, the attacker can potentially access pages in a way unanticipated by the web developer. By doing so, the attacker can scale across control mechanisms and impersonate legitimate users. The attacker could also serve values indirectly without prediction or detection. Buffer overflow occurs when a program tries to write more data into memory than the memory is capable of holding. When this occurs, writing outside the capacity of the allocated memory can corrupt data, crash a program, or allow the execution of malicious codes. Padding Oracle decrypts encrypted data provided by the client. The existence of this oracle allows the attack to decrypt data and encrypt arbitrary data without the knowledge of the key used in the encryption process. Content spoofing is a form of phishing which occurs when an application fails to handle user data properly. In this case, an attacker can supply content to an application typically via a parameter value that is reflected to the user. This in turn presents the user with an illicit page under the context of a trusted domain. Humans, and users specifically, crave routine. Most everyone wants to have a single password for everything, and for that password to be short and easy to remember. Further, when password policies require a user to frequently change their passwords and mandate a minimum complexity, users will sometimes rely on writing down their passwords and keeping it at their desk. Social engineering is a blanket term for cyber attacks that target the humans of a network rather than the systems to gain access. These attacks come in the form of phishing emails asking for login credentials, shoulder surfing, where the attacker tries to observe a user entering their credentials, or tailgating, when an attacker follows a user into a secure location without their knowledge. As noted earlier in the presentation, insider attacks are a major concern as they are difficult to detect and can be devastating due to their level of access of some users. These attacks will either strive to exfiltrate data from the network or try to upload malicious data or programs into the network to cause damage to the company. Attribution in cybersecurity is the technical process of tracking and identifying the originator of an attack vector. This process aims at identifying the identity of the perpetrator, the origination, location, and the techniques used in the malicious act. This process is often conducted by forensic experts in conjunction with law enforcement agents who have access to large databases within and outside the impacted jurisdiction. There are many specialized techniques adopted in attribution, but definitive and accurate cyber attribution is not always possible. Forensic experts may use analysis tools, scripts, and programs which allow the disclosure of programming language, compilers used, compile time, library used, order of execution events, and other related information. Investigators may also attempt to analyze any metadata connected to an attack. This metadata includes IP addresses, email data, hosting platforms, domain names, domain registration information, and data from outsourcing parties. Though these data points can easily be faked by the attacker, an analysis should never be ruled out as there might be linkages. Investigators may also take an examination approach. Here, the techniques, procedures, and tactics used in the attacks are examined. Often, cyber attackers have distinct and recognizable styles and signatures of attack. In this case, investigators will be able to link and identify the perpetrators based on clues and related attack methods. The following 3 slides will cover the cyber vulnerability assessment and the various vulnerabilities that our team has discovered and the impact that they could have on us. This full cyber vulnerability assessment is in the appendix of the package that was handed out at the beginning of the meeting and will be available for questions at the end of the briefing. Our recommendations to improve our network security posture are as follows. For hardware, maintain and improve current physical security access controls. Consider including biometric access controls in more locations. Implement group policy requirements to lock down USB ports. Disable all unused network jacks in all buildings. Introduce employee job rotation to verify employee activity and discourage malicious activity. Introduce regular access log reviews. Introduce regular database audits. For software, improve firewall rules to limit network traffic entering and exiting the network. Restrict all network traffic to only secure protocols. Introduce regular scans and updates for all antivirus and anti-malware software. And include regular security patching for all workstation and servers. On behalf of Team Canada, I would like to thank you for attending this briefing. I would now like to open it up to some questions and answers, and once again, thank you very much.